Hello students. Today we are going to start with Maths 2 chapter number 5 Quadrilaterals practice set 5.1. So the very first problem of this practice set is diagonals of a parallelogram WXYZ intersect each other at point O. If angle XYZ equal to 135 degree, then what is the measure of angle XWZ and YZW? If length of OY is equal to 5 centimeter, then length of WY we have to find out. So the very first thing that is given to us is quadrilateral WXYZ is a parallelogram. Okay. Now here WXYZ is a parallelogram. The opposite angles of parallelogram are congruent. What we have to find out, what is given to us, XYZ measure is given to us, and we are supposed to find out XWZ and YZW. Now here for your information, let me clarify, as the figure is not clear. This is X, this is Y, this one is Z, and this one is W. Okay. Now which angle is given to us? Angle XYZ, means this angle is given to us, right? And we are supposed to calculate XWZ. Okay. To find out XWZ, we have to go with the property of opposite angles, that is angle XYZ is equal to angle XWZ. Angle XYZ is 135, so angle XWZ is 135. This is one of the part that we have solved, right? Now we will move on to the second part. The second part is I'll again write the names as it has vanished. Z, W. Now we have to find out YZW. Okay. Now we all are aware that adjacent angles of the parallelogram are supplementary. Okay. So here XYZ, the given angle, plus angle YZW, these are adjacent angles. Their sum is supplementary, means it is equal to 180 degree. So here angle YZW plus angle XYZ equal to 180 degree. Substituting the value, angle YZW equal to YZW plus 135 is equal to 180 degree. So angle YZW is equal to 180 minus 135, that is equal to 45 degree. Okay. Now the next part, the third part of it, what is given to us is we have been given OY, means the point of intersection till Y. The measure is given as 5 centimeter, and we are supposed to calculate WY now. Now we all know that diagonals of parallelogram bisect each other. Okay, bisect each other means it divides into two equal parts. So half is given to us and we have to find out full. So for calculating full, I have to multiply the half with 2. Okay, so 5 is to be multiplied with 2. So 5 2s are 10. So WY is equal to 10 centimeter. In this way, we have completed problem number 1 of exercise 5.1. Now we move on to the second problem of it. So for the second problem, what is given to us is in a parallelogram ABCD. Okay, angle A is given to us as 3x plus 12y plus 12, and angle B is given to us as 2x minus 32 degree. We are supposed to find the value of x and we are supposed to find the measure of angle C and D. Right? Now here we all know that angle A and angle B are supplementary. Okay. This is angle A over here, angle B, angle C and angle D. Okay. Now measure of angle A is given to us and measure of angle B is given to us. Both the angles are adjacent to one another. Adjacent angles are supplementary. Therefore angle A plus angle B is equal to 180 degree. Therefore, their values, that is 3x plus 12 is angle A and 2x minus 32 is angle B, equal to 180 degree. When I add that, I get 3x plus 2x is 5x and minus 12. 32 minus 12 will be 20. Minus 20 equal to 180. Okay. Now here 5x will be equal to what? It is equal to 180 plus 20. When I add that, 5x will be equal to 200. So x is equal to 40. So value of x is calculated. Now what we have to calculate? We have to calculate C and D. Now angle A is equal to angle C, right? First we have to find out what is angle A. To calculate angle A, what I have to do? I have to substitute the value of x in angle 3x plus 12. So the same thing I have done. 3x plus 12, that is 3 into 40 plus 12. So 3 40s is 120. 120 plus 12 is 132. Now angle A is equal to angle C, as they are opposite angles. So angle C will also be equal to 132 degree. Similarly, angle B we have to find out to get the value of D. So in place of x I have to substitute 40. So it is 2 into 40 minus 32, that is equal to 48. So angle B is equal to angle D. Therefore angle D is also equal to 48 degree. I hope it is clear. Now we move on to the next problem, that is problem number 3. In that, what is given to us is perimeter of the parallelogram is 150. Okay, it is 150, and one of this greater side is given to us. One of its side is greater than the other by 25. Find the length of all the sides. So we'll consider that let the smaller side be x, so bigger side will be x plus 25. Okay, same I have written over here. Then perimeter is what? 2 times L plus B. Substituting the values, so length is x plus 25 and breadth is x. So it is 2 times x plus 25 plus x equal to 150. So it is 2 times 2x plus 25 equal to 150. It is 4x plus 25 50 equal to 150. 2 is multiplied with each term in the bracket. So it is 4x plus 50 equal to 150. Then this 50 will go to the other side. So it will turn out to be minus. So 4x equal to 150 minus 50 will give me 100. So 4x is equal to 100. So x is equal to 25. Now, the length of one side is 25 and the length of greater side is 50 degree. How 50 centimeter? Because in that 25 we have to add 25 again, right? To get the length of the other side, right? Here, opposite sides of parallelogram are congruent, right? So the length of the sides of parallelogram are 25, 50, 25, 50 centimeter. So this is how we have completed the third problem of exercise 5.1. Now we move on to the fourth problem of exercise 5.1, in which we have been given the ratio of the measures of two adjacent angle, that is equal to 1 is to 1 is to 2, and we are supposed to find the measure of all the angles of a parallelogram. Okay, now whenever it is given in the form of ratio, we have to consider the common multiple. So common multiple is taken as x. So measure of one angle or be x and the other will be 2x. Now adjacent angles are supplementary. So x plus 2x equal to 180. 3x equal to 180. So x is equal to 60. Therefore measure of one angle is 60 degree and the measure of other angle is 120. Opposite angles are congruent. Therefore measure of angles of parallelogram is 60 degree, 120 degree, 60 degree, 120 degree. I hope it is clear. Now we move on to the fifth problem of the exercise. In fifth problem, the diagonals of the parallelogram intersect each other at O. AO is given to us as 5 and BO is given to us as 12. And AB is given to us as 13. We have to show that the given quadrilateral, the given parallelogram is a rhombus. Now for the rhombus, what are the properties of the rhombus? That all sides are equal. So in case of parallelogram, it's not possible. Okay, then we have to move on to the next property, that opposite angles are congruent. So that is also okay. But what is given to us, we have to move on the given line. Diagonals are given. So what can you say about the diagonals of the rhombus? Diagonals of the rhombus are perpendicular bisector of each other, and diagonals of parallelogram bisect each other. Means we have to show that it is perpendicular also. Okay. For showing perpendicularity, what we have to use? We have to go with the Pythagoras theorem. Okay. So what do the Pythagoras theorem says? That the hypotenuse square is equal to one side square plus other side square. So to come on that, very first thing we have to go with the Pythagorean triplet. Now, which is the largest side over here? AB is the largest side, that is 13. So square of 13 is 169. Then the sum of the squares of the other two sides, that is AO square plus BO square, that will be equal to 5 square plus 125, that is equal to 25 plus 144, that is equal to 169. Now 13 square is 169 and the sum of the squares of the other two sides is 169. From here we come to the conclusion that 13 square is equal to 5 square plus 12 square satisfies the Pythagorean triplet. So the diagonals of the parallelogram are perpendicular bisector of each other. Therefore the given parallelogram ABCD is a rhombus. Okay. Now we move on to the next problem, last problem of this exercise. So in that problem, what is given to us? Given part is quadrilateral PQRS is and quadrilateral ABCR is our parallelogram, right? Now here angle P is given to us as 110 and we are supposed to find the measure of all angles of ABCR. Okay, now where is this ABCR? That first we will clarify. Now here it is A, here it is R, here it is B, and here it is C, right? So, and measure of outer quadrilateral, one angle is given to us as 110, that is angle P. Angle P is 110. So, the opposite angles of parallelogram are congruent, outer parallelogram, that is PQRS. So, angle R will also be 110, right? As angle R is 110, then we move on to the inner parallelogram, that is ABCR. And in ABCR, angle R is equal to angle B, right? Opposite angles of parallelogram are congruent. So, angle B will be equal to 180 degree. Now, if I have to find out angle C, then I have to go with the property of adjacent angles. Adjacent angles of parallelogram are supplementary. Okay, so angle B plus angle C, or you can go angle R plus angle C equal to 180 degree. Substituting the value 110 plus angle C equal to 180 degree. So angle C is equal to 180 minus 110. Angle C will be equal to 70 degree. Now angle C is equal to angle A, right? So measure of angle A is also equal to 70 degrees. So B and R are 110 and A and C are 70 degree. Clear? Now we move on to the next part in the means I hope this part is clear to you now. So thank you. Tests of parallelogram. If pairs of opposite sides of quadrilateral are congruent, then the quadrilateral is a parallelogram. These are converse of the previous theorem. Okay. So what is given to us? Given part is one of the quadrilateral is there. We'll name it as PQRS. What is given? Opposite sides of the quadrilateral are congruent. Means opposite side PS and QR will be equal. PS and QR are equal and PQ and SR are equal. What we have to prove? We have to prove that quadrilateral PQRS is a parallelogram. We have to draw the diagonal PR. I'll just go with the figure. Here the figure is given. Here suppose it is P, Q, R and S. So PS is equal to QR and PQ is equal to SR. What we have to do, we have to prove that it is a parallelogram. For that, what we have to do, we have to draw the diagonal. Okay, done. Now we move on to the next slide where the proof of the given theorem is given to us. So the next slide, what is given, we will go with that, right? So we have drawn PR as the diagonal. So the given figure is divided into two triangles, okay, triangle PQR and triangle PSR. In this triangle, PS is equal to QR and SR is equal to PQ. This is given to us. Then PR is the common side. So PR is equal to PR. So these two triangles are congruent to each other by which test? By SSS test. Okay, as they are congruent, now we move on to the next part of it. That is angle SPR will be equal to angle PRQ or QPR. Okay, now here similarly angle PRS is equal to angle RPQ. Okay, these are corresponding angles of congruent triangles, but the angles so forming over there are alternate angles formed by the transversal PR and segment PS and QR. Okay, so here the angles so formed are alternate angles. So from here we come to the conclusion that PS is parallel to QR. Okay, this is alternate angle test for parallel lines. Similarly, we can show that PRS is equal to angle RPQ. Alternate angles, as PR is the transversal and on PQ and SR. So PQ is parallel to SR. Okay, alternate angle test from 1 and 2. What do we conclude? We come to the conclusion that quadrilateral PQRS is a parallelogram. Okay. So we have started with the given part. One of the common side is there. We have proved that two triangles are congruent by SSS test. Then we have come to the angles, corresponding angles of congruent triangles. But here the angles of forming are alternate angles. So the sides which are making the two angles as alternate, so they will be parallel to one another by alternate angle test. So the opposite sides are parallel also with the congruency. That's why the given quadrilateral is a parallelogram. I hope it is clear. Now we move on to the next theorem. In that theorem, what we have been given, if both the pairs of opposite angles of a quadrilateral are congruent, then it is a parallelogram. Okay. Now here the figure is given to us. EFGH is a parallelogram. EFGH is a quadrilateral in which opposite angles, that is angle E is equal to angle G and angle F is equal to angle H. We have to prove that quadrilateral EFGH is a parallelogram. I'll just name this as E. This is E. Okay, the other part is clear. Now I'll suppose that angle E and angle G as equal to X. Okay, and angle F and angle H as equal to Y. Right? Now sum of all angles of a quadrilateral is 360. So x plus y plus x plus y will give me 360. Okay. Now there are 2x. So 2x plus and 2y. So 2x plus 2y will be equal to 360. So what will be x plus y? X plus y naturally it will be 180. So angle G plus angle H is equal to 180 degree, right? Now these two angles are forming interior angles by the transversal HG, okay, of G, F and HE. Similarly, I can show that angle, G, angle G plus angle F is equal to 180 degree, right? So HG will be parallel to EF by interior angle test of our parallel lines, okay? From here we come to the conclusion that given quadrilateral is a parallelogram from 1 and 2, okay? And by the definition of parallelogram. I hope it is clear. Now we move on to the next theorem. In next theorem, what is given to us? If the diagonals of a quadrilateral bisect each other, then it is a parallelogram, right? Given part. Diagonals of quadrilateral ABCD intersect each other at point E such that AE is equal to CE and BE is equal to DE. Okay. Now here, what is given to us? ABCD is sorry, we have to prove that ABCD is a parallelogram. Okay. Now, when you draw two of the diagonals, you get two triangles over here. Actually, you get four triangles and you have to consider any two triangles over there. So, I have considered triangle AEB and triangle ACD. So, triangle AEB and triangle ACD. Okay. Now, in this, EC is equal to AE, right? Then EB is equal to ED, okay, and these two angles are equal to one another, that is angle AEB is equal to angle CED, right? Now the two of the triangles are congruent to each other by which test? They are congruent to each other by SAS test of congruency, okay? As two of the triangles are congruent, their each and every angle inside will be congruent to each other. Now we have to focus on the angles, okay? So which two angles I'll be considering? I'll be considering So which two angles I'll be considering? I'll be considering angle BAE is equal to angle DCE, right? And which can be written as angle BAC is equal to angle ACD, as E lies between A and C. From here, we come to the conclusion. Now, which angles they are forming? They are forming alternate angles by the line AB and DC, where AC is the transversal. Okay, we come to the conclusion that AB is parallel to DC. By which test? By alternate angle test for parallel lines. Similarly, I can show that AD is parallel to BC. Okay, so this will be my equation number 2. Now from 1 and 2, quadrilateral ABCD is a parallelogram. That is also by definition that the opposite sides are parallel, then the given quadrilateral is a parallelogram. Clear? Move on to the next theorem. In this theorem, so here we start with the next proof. A quadrilateral is a parallelogram if the pair of opposite side is parallel and congruent. Okay. Now here what is given to us? A quadrilateral is given. The picture is not very clear. I'll just write the vertices so that the points will be clear to you. So this is A, B, C, D, right? Now here, okay. Now here, quadrilateral ABCD, and CB is equal to DA. CB is equal to DA, and CB is congruent to DA. Okay, this CB is congruent to DA and it is parallel also. Okay, we have to prove that the quadrilateral is a parallelogram. We have drawn the diagonal BD such that it is a transversal as CB is equal to DA. So, which of the alternate angle will be congruent? These two angles will be congruent to one another. So, which are they? CBD is equal to angle ADB. CBD it is. So, here it is B and D. Okay, is equal to angle ADB. So the two triangles are forming over there. Which are the two triangles? Angle BCD and angle BAD. Okay. Now here angle CBD is equal to angle BDA, alternate angles. This side is equal to this side, and this is the common side. Okay. So the two triangles will be congruent by SAS, test of similarity. Again, here the correction is there. It is angle CBD. Okay, CBD is equal to angle ADB. Okay, so the two triangles are congruent by SAS test. Okay, so here angle CDB will be equal to angle ABD. CDB is equal to angle ADB. Okay, so therefore CD is parallel to AB, and again the alternate angles test of parallel lines. So the given quadrilateral ABCD is a parallelogram. We'll repeat one more time. Okay, so I hope it is clear. Now we move on to the next. That is the practice set of 5.2, in which only 3 problems are there for this year. In figure, quadrilateral ABCD is a parallelogram. Okay, P and Q. This P and Q are the midpoints of AB and DC. We have to prove that quadrilateral APCQ is a parallelogram. Okay, now we have been given that ABCD is a parallelogram. So AB is parallel to DC. So half of AB will be parallel to half of DC. Half of AB will be equal to half of DC. What is half of AB? It is AP. Half of DC is CQ. So AP is equal to CQ, right? Now as AP is equal to CQ, opposite side is parallel also, opposite side is congruent also. So the given quadrilateral is a parallelogram. Okay. So from here we come to the conclusion that quadrilateral APCQ is a parallelogram. Clear? Now we move on to the second problem. Using the opposite angle test of a parallelogram, prove that every rectangle is a parallelogram. Okay. Now, given part is quadrilateral ABCD is a rectangle. We have to prove that quadrilateral ABCD is a parallelogram. Okay, we have to use the opposite angle test of parallelogram. Now, rectangle, we all know each and every angle is 90 degree. Now, each and every angle is 90 degree means A is equal to B and C is equal, A is equal to C and B is equal to D, each 90 degree. Now here opposite angles are congruent means the given quadrilateral is a parallelogram. Clear? Now we move on to the last problem, very interesting problem. Okay, so what is given to us? Proof that the quadrilateral formed by the intersection of angle bisector of all angles of parallelogram is a rectangle. Now quadrilateral ABCD is a parallelogram. This outer quadrilateral is a parallelogram. Okay. So as it is a parallelogram, adjacent angles are supplementary. So angle ADC plus angle BCD is equal to 180 degree. Now multiply it with half. So half of angle ADC and half of angle BCD is equal to half of 180 degree. Now what is half of angle ADC? Half of angle ADC is angle PDC and half of angle BCD is PCD. Okay. Now angle PDC plus angle PCD is 180 degree. Fine. Now come to the triangle PDC. Come to the triangle PDC. So here is a triangle PDC. So this is triangle PDC. Now this two angle is 90 degrees. So obviously this angle will be 90 degree. How come? Sum of these two is 90 plus angle DPC is 180. Okay. So 90 plus angle DPC is 180. So angle DPC is 180 minus 90 equal to 90 degree. Okay. So measure of angle DPC is 90. So, but obviously the vertically opposite angle will be congruent to each other, right? So as DPC is 90 degree, wait, DPC is just, now this DPC, this angle is 90 degree, fine. Similarly, I can show that this particular angle on the same line, I can show that these two angles are equal. They are forming opposite angles, right? So I can also show that the angles forming at this point are also equal. Okay. So opposite angles of the given quadrilateral are congruent. Therefore, the given quadrilateral is a parallelogram. That is quadrilateral PQRS is a parallelogram. Till here it is clear, I think so. Now we move to the next part of it, last part of it. Now DPC is 90 degree, that is SPQ is 90 degree. Why? Because S lies between D and P and Q lies between P and C. As I told you, I can show that SRQ is 90 degree, ASD is 90 degree. So on that basis, BQC will be 90 degree. Okay. PSR is equal to ASD, vertically opposite angles. So PSR is 90 degree. Similarly, PQR is 90 degree. Now in quadrilateral PQRS, all angles are 90 degree. Okay. So PQRS is a rectangle. Clear? So here we end up with exercise 5.2. In the next video, we'll start with the next exercise and theorems related to it. Thank you very much.